In this lesson, I'm going to cover AWS Global Accelerator. And let's start off with a diagram to help you understand what this service actually is. Here we have load balanced solutions, so we have some kind of application sitting behind a load balancer in US East 1 and EU West 1. So two different continents here. Users in the US want to access this application, and we can assume here that the application is identical behind these two regions. These are here for high availability and redundancy. So users in the US speak to Amazon Route 53 to resolve what dctlabs.com's IP address is. Okay, so Route 53 is the DNS service being used here. Now, what's going to happen here is Route 53 responds with these two answers. Okay, these are two static public IP addresses, and these are actually called Anycast IP addresses. More on that in a moment. So now the users know that they can connect, or the computers know that they can connect on these IP addresses. What happens next is the user traffic is going to ingress using the closest edge location. So Global Accelerator is utilizing the Amazon CloudFront network of edge locations, and there's hundreds of those around the world. So these users are somewhere in the US, so they're going to get directed to an edge location somewhere close to where they are physically located. That means the shortest distance possible to get into the AWS Global Network. And once they're in the AWS Global Network, of course, the latency is more consistent, the bandwidth is good. So that's why we want to leverage the AWS Global Network here. So the users get directed to the edge location, and then from there, Global Accelerator, which is listening on these IP addresses, is able to accept the incoming traffic, and then it chooses where to forward it. Now, I mentioned that there's something called an Anycast IP address. What does that actually mean? So normally we're talking about unicast IP addresses, broadcast IP addresses, and multicast. Now, the IP that's associated with, for example, a web server, that's a unicast IP address. And it's actually attached to a single network adapter somewhere in the world. It's not going to be in multiple places at the same time. So if you have a web server that has a public IP address, it's physically located somewhere in the world. But what we want to do is we want to have two public IP addresses that are identical for anyone, anywhere in the world, to connect to the edge location that's closest to them. That's how we use an Anycast IP address, which actually the routing across the internet is going to forward you to the closest locations. So it's kind of like those addresses are actually physically present in multiple places in the world. Depending where you are, you get directed to the closest one. So Global Accelerator then utilizes the global network to forward the connections to the relevant regions. Now in this case, the green line indicates where the traffic actually has gone. The purple line is purely the AWS Global Network. So those are potential paths. But the users have been directed to US East 1 because they are in the US, and therefore US East 1 is closest to them. This is routing to the most optimal endpoint. So this is a healthy endpoint. It's closest to the users. Therefore, the traffic has gone there because that will be the best performance for those particular users. Now, if for some reason that site fails or the load balancer fails or something like that, then those users will be reconnected to another region. So the next best, or the next most optimal region, which in this case is EU West 1. So that's users being redirected to another healthy endpoint. And there could be more endpoints available as well. Here we're just showing two. So this service operates at the network layer. So it's layer 4 of the OSI model. It provides static IP addresses as a fixed entry point for your applications. Those are the Anycast IP addresses. And you can bring your own as well. Performance, it improves performance by leveraging the AWS Global Network backbone, reducing network latency for people around the world. It performs health checks to check that it's routing traffic to the most optimal and healthy endpoints. And it supports TCP and UDP traffic, so you can use this for a wide variety of different applications. With CloudFront, for example, you're only able to utilize HTTP and HTTPS. You cannot run traffic through CloudFront if it's using some custom TCP or UDP port. That's where Global Accelerator comes in. In terms of use cases, it's ideal for non-HTTP use cases. So for HTTP and HTTPS traffic, port 80, port 443, utilize Amazon CloudFront. For anything else, you can utilize AWS Global Accelerator. So Global Accelerator can then be used for a variety of different use cases where you're using any TCP or UDP port.